One of the last things we're going to look at are some special power rules that come about. So if we have, oops, let me undo that there. I made everything bright green here. Oh, just right and bright green. So if we have some number taken to the 0 power, we say that is equal to 1. We can see this if we look at it this way. If I have a to the first over a to the first, my quotient rule said that was a to the 1 minus 1, which equals a to the 0. But we also, back from division, anytime we see some number divided by itself, as in 3 over 3, or x over x, or 58 over 58, anytime some number is divided by themselves, they all equal 1. And here we have a to the first over a to the first. So I can say that's also going to equal 1. So for any value of a base to the 0 power equals 1, except a cannot equal 0. And that's because of that pesky division by 0 thing. So a itself can't equal 0. So what does this look like? Well, x to the 0 power is 1. Y to the 0 power is 1. 3 to the 0 power is 1. 3x cubed y to the 5th, all taken to the 0 power, is 1. Anytime you raise a quantity to the 0 power, the answer is 1. The other special thing we're going to want to look at here, let me get a little more space here to do some more drawing. Sorry about this, but we'll just develop some more space. I'll come down here. I think I'll have to paint it black so I can, yep, so let me paint all this black for you here. So I can write. Just a second. Good. All right. Sorry about that. Just changing the screen around. Get back up here. There we go. So the other special thing we have is negative powers in general. So if I have a to the negative 3, this is telling us that I have some type of subtraction going on. Well, subtraction came from our quotient rule. So I could think of a to the negative 3 as a to the 0 minus 3. If I turn that into the quotient rule, that was a to the 0 over a to the 3, or 1 over a to the 3. And what negative powers tell you is you're on the wrong side of the fraction bar. So we tend to want to talk about everything in terms of positive exponents. So when you see 3x to the negative 2, let me make my 2 look like a 2. 3x to the negative 2. This power is only attached to the x. So the 3 stays where it is, and the negative sign tells the power to go downstairs. So if we're looking at a collected fraction, we'll say y over z all to the negative 2. Well, my power to the quotient rule is going to say I have y to the negative 2 over z to the negative 2. But writing these negative exponents as positive, this is saying z is on the wrong side of the fraction bar, so it should come upstairs. And this is saying y squared is on the wrong side of the fraction bar, so it should go downstairs. And so the negative signs pull you to the other side of the fraction bar. Remember, this rule here distributes the negative 2 to each part. And then the negative sign pulls that term through. So let's look at this in pieces here. So I'm going to look at, let's go nice bright yellow, r cubed over s to the 4th all to the negative 3. So I have a power quotient rule that says I have r to the 3 times negative 3. That's because this negative 3 is getting multiplied. And let me use plum for that. I like plum. So that negative 3 is getting multiplied by this power here. We see that come across right there. And then on the bottom part of my fraction, on the denominator, I have 4 times negative 3. And we'll use a, let's go for a turquoise. Put me down here. Because our power quotient rule said that this power on the outside here gets multiplied to each exponent in the fraction. So we'll do our multiplication here, and this gives us r to the negative 9th over s to the negative 12th. But we don't like writing negative exponents. So the negative exponent is going to tell us to switch sides. So this is s is going to move upstairs, and it's going to become s to the 12th. And r is going to move downstairs and become r to the 9th, but downstairs. And so a negative exponent moves the variable and the power to the other side of the fraction bar. But notice we lose the negative signs in the process. And so you can think of it of a way as moving upstairs or downstairs. All right, so tonight's homework is going to really play with these power rules. And then in tomorrow's lectures are going to deal with scientific notation, and we're going to start creating polynomials now that we've had the review on the powers. If you have any questions, please